Welcome to this talk about approaches for application request throttling. Before we start, I want to ask you, who of you is building web applications or APIs and so on? Okay. Who of you are currently throttling their applications already or applying rate limiting and so on? Not too many. Okay, that's good, because then you are the perfect audience for this talk. I want to talk about how we at our company approached application throttling and gradually added application request throttling to our application. And sort of give you the things that you should be thinking about. And I will start this talk by giving you like the quick introduction to why you want application request throttling and what would be the naive way of implementing it. And then we will look into what other things that you should be thinking about. I'm Maarten Balliauw. I come from Belgium. My native language is Dutch, and I try to do English and one word of Russian. During the day, I'm a developer advocate at JetBrains, and at night I built MyGit, which is the software as a service solution that I will be using as a case study for this talk, basically. If you're interested in anything about cloud or web or whatever, feel free to follow me on Twitter or check my blog and so on. All right. Let's first start with perhaps an inconvenient truth about users and traffic patterns. Users typically do not know what they are doing, but before we laugh about that, they don't know that and they mean well. So it's not their fault that they are misbehaving on our application, it's because our application is not behaving correctly in front of the user. So that's a really important distinguishment that we should be making there. Then we will look into rate limiting and what things you should be looking into and what things you should be thinking about when applying it in your application. All right, users. On MyGit, we, as a software as a service, I don't know if you know this service, what we do is we host private packages, whether it's NuGet packages, Maven packages, NPM, Bower, whatever you want to host there, you can find it on MyGit and you can create an account and host everything there. Of course, as a package repository, what we have is an HTTP-based API that users can use to either publish their packages onto MyGit or retrieve the packages from MyGit during, for example, a NuGet package restore. The application is basically two things. There's a web UI where you can manage your users, where you can manage what license that a specific package belongs to and so on. Or you can use the API, which is typically what the package manager will be using. So if you do a NuGet restore, for example, you will be doing a lot of GET requests on MyGit, and we serve them up to your NuGet client. Now, our architecture, we sort of thought from the beginning about becoming popular and having lots of traffic and so on. And we came up with this architecture of having a front-end web farm, and then on the back end, we would have a worker farm that would just process whatever comes in. So for example, when you upload a package to MyGit, what will happen is we post a message on a queue somewhere, and then on the back end, some worker process will pick up that message and make sure that we check if your package contains symbols, for example. We update the latest versions. We may update the download count. We do some search engine indexing and so on. So a lot of tasks that can happen independently from one another, but we don't want to do them on the front end, because if someone uploads a lot of packages to MyGit, we want to be sure that the front end can respond, and even then, it doesn't really matter if our indexing takes 15 seconds or maybe 1 minute if it runs on the back. That's a really nice architecture, because even if we have a lot of traffic on our web farm, our worker farm can just consume messages, and yes, the number of messages on the queue may grow, but still everything flows through and will work eventually. Now, what could possibly go wrong with this architecture? Unfortunately, we had to find this out while running the application. What you can have is too many uploads coming in. So for example, if you have 10,000s of requests per second uploading packages to MyGit, what will happen is we will need to scale our application. First thing that will happen is that IIS inside of our server will start scaling and adding more worker threads and making sure that it can process all the incoming traffic. We still have to check application credentials. Do you still have an active subscription? Are you still allowed to push packages to MyGit, etc.? But still, the front end will scale perfectly. First IIS will scale, then we will just add more servers and we will be able to cope with the loads. Now, unfortunately, because of our backends that consumes the queue, this means that in a busy moment, we may have some delays on these queues. So it could be that for indexing your package on MyGit, it could take up to 5 minutes before the package actually shows up in the website because of this delay between the front end and the back end. So that's an issue. It's not really a big issue, but it's not nice when users expect their packages to be there and it takes 5 minutes for them to show up. Also, too many uploads that are too slow is also an issue that we faced. There's a lot of users in countries that don't have splendid internet connections. And what we see is if they upload to MyGet, we see that the upload is typically quite slow, and that still consumes processes on IIS. IIS needs to scale up worker threads and IO threads to basically copy from a network stream to our backend and store it somewhere in storage. So we still need to scale for those slow requests, even if it's maybe not a lot of requests coming in. But still, we have an issue there. We somehow want to shape the amount of traffic that comes in and sort of block the excess traffic that we have there. Package managers are crazy. If you look at NuGet, or if you look at Maven, for example, or NPM, if you have multiple repositories that you consume packages from, all those repositories will typically, not all package managers do this, but NuGet, for example, definitely does this. The NuGet client will hit our feeds for every single package that you want to download. So if in your solution you have 200 packages, and 190 of those packages are hosted on NuGet, and only 10 of those are on 2 MyGet feeds, we will still get 400 requests checking all those 200 packages. Most of them will end up in a 404, but we still have to check if you have access to this feed. Are your credentials okay? Can you actually consume this specific package and so on? So we still have to run that business logic that we have in the application for those 400 requests that come in this scenario, even though only 4 of them or maybe 5 of them will succeed in the end. So that's a big waste of resources, but still the package manager works like this, so we have to cope with that traffic. Some other examples. Actually, I have a nice slide in a bit. You may have some forms on your website. So for example, a registration form or a login form or whatever. You may see people starting to abuse that thing to sort of brute force their way into your application. Imagine you are a credit card processor. You may see some traffic trying all sorts of random credit card numbers with random expiration dates to see if the credit card actually triggers and to find a valid credit card number and so on. You may have robots like Yandex or Google or whatever consuming your websites and consuming the pages that are on your website, but giving you too much traffic. Imagine you build a shopping cart, for example, and you keep the shopping cart in a session variable somewhere. Imagine Google or Yandex come along and they add all your products that you have in your catalog into that session variable. Your web server will probably not like 20,000 items in a typical shopping cart there. A recent real-life example, last Tuesday, I was really happy seeing this amount of emails in my inbox, all people wanting to create a MyGet enterprise account. I was like, yes, rich. Unfortunately, this was a spider checking for SQL injection on our website. So we basically, this one form is just you fill out the form and it sends an email to us. This form was hit 600-something thousand times to try all sorts of values there. So I can tell you Outlook doesn't like this number of emails in the inbox. Really doesn't. But still, even our stupid form that just takes input, sends an email, is subject to things that could potentially go wrong if there's a lot of requests coming in there. So in the end, we need some way to throttle or rate limit the number of requests that come in and the number of requests that we actually want to handle with our application. I may use the two terms, rate limiting and throttling. They both sort of mean the same. So if you hear me say throttling, I mean rate limiting. If I say rate limiting, I mean throttling. So infinite loop, right? Okay, rate limiting. What is rate limiting? Well, it's basically limiting the rate of whatever comes in. Typically, you see most applications rate limit the number of requests that come in. So typically, you limit to, say, 10 requests per second that can hit this specific part of the application. You can do rate limiting on number of requests, but if you do, imagine you are Netflix or you're building a streaming service or whatever, you may want to not limit on the number of requests, but you may want to limit the bandwidth that a user can consume from your server. Or you may limit something else. So rate limiting doesn't really apply to only the number of requests per second or per minute. It could be bandwidth, it could be any metric that you use in your application. Doing all of this, rate limiting, helps eliminating unexpected traffic patterns. So if you, for example, get this spam bot trying all this form input on our website, we would eliminate that if we would only allow 1 request per second on that form, for example. We may still get a number of them, but they will probably give up after a while. Unwanted traffic patterns. Again, this was a really unwanted traffic pattern because I wasn't really looking forward to cleaning out 600,000 messages from my inbox, but still I had to do it. Unwanted traffic patterns, we didn't block or rate limit that specific requests. Potentially, you want to also limit damaging traffic patterns. If you would have this shopping cart, for example, with the 20,000 items, if your application would go down by adding 20,000 items in the shopping cart, you may want to set a limit there and stop requests from coming in or requests from being handled if you see that it will start crashing your servers, for example. Damaging unwanted and unexpected traffic patterns can be both intentional and not intentional. You will see that most users just try something on your application and they will bring it down or they cause trouble by just accidentally trying malicious patterns. We've had, for example, a user deleting all the packages on their feed in MyGet. Typically, we have one button that says delete all. Are you sure? Yes, and it deletes all the packages in one go. This user was just hitting our API and deleting 60,000 packages one by one. That was unexpected traffic that we didn't really want, but still the traffic happened. The user didn't mean to do bad, but in the end he did bad because we had a lot of queuing involved there. So what do you rate limit? I have this wonderful saying, which is rate limit everything. Even that one form that we forgot to rate limit. So rate limit everything. You may be asking yourself, why would I rate limit everything? Well, I want to tell you what you really want to rate limit. Rate limiting should apply to everything that could slow down or break your application. Typically, everything that depends on a scarce or an external resource. Could be your database, could be the CPU, could be memory, could be the database, could be an external API. I think you get the picture. Everything that is a resource that is limited in your application or in your hardware or your setup is basically a good reason to start applying rate limiting in your application. So everything, yes, since this is the typical application, if you're using the CPU, memory, disk I/O, or a database or whatever, you want to start rate limiting it. So yes, everything. Right, let's do this. Let's take the naive approach and start rate limiting. What would you need if you would start rate limiting in your application? Let's say we want to store the requests coming in a database. I don't want to store all the details about the request. What I want to store is who is coming in, what is the user doing doing in our application, and when did this action occur. Because based on that data, I can do rate limiting on the user, I can do rate limiting on user plus action, I could do rate limiting on action, and I can do things like calculating the number of requests per second, per minute, per hour, and so on. So I have all that data if I just store these 3 columns. On the database side, what would my logic look like? Well, simple. If I would have a web API application or an MVC application, just create an application filter attribute. And in that attribute, you select the count of events where user and action are the same thing that you are currently doing. You look at the number of requests coming in or the number of entries in the database. If it's above the threshold you want to set, then you stop serving requests to this user, right? And of course, every time a request comes in, you want to store it in the database. And at some point, you also want to do a cleanup because otherwise your database will be full and so on. So sounds like a sound approach, I guess, right? Okay, let's do this. I actually created an application like this. And in this application, it's an ASP.NET Core application. I added a filter to all actions in my code, a rate limit filter that I will look into in a bit. My rate limit filter makes use of an events context. So I'm using Entity Framework to store the data in my database. This events context, what does it look like? Well, I have my events context, which contains events. And an event is simply a user identifier, action identifier, and when did the action happen. So in my rate limiting attribute, what I will be doing is whenever you come in, whenever the action starts executing, I determine an identifier for the user. If you're logged in, I will store your username. If you're not logged in, I will store anonymous. Of course, this is a very, very naive approach. If there's two users that are not logged in, they will have the same user identifier in this case. So keep that in mind. I do want to add the IP address there, so in case I join from Belgium on this website and someone else comes from Russia, then the user identifier would still be distinguished based on IP address. Okay. I determine the action. I want to store that I'm on my home controller, about, or on my hello world controller, this action, etc., whatever I have in my application. Then I want to check if we are rate limited. What I do is I count the number of events in my database where the user identifier matches, where the action identifier matches, and where the when is larger than the periods that I want to throttle on. So my period will be 5 seconds, and when there's more than, I think, 5 requests in this case, yes, more than 5 requests in this period, I will simply return a status code 429, which is too many requests. If not, I will just continue by inserting an event and deleting the old events that are no longer needed in this database to sort of keep my database clean. Right, let's run this. And what you will see is nothing, and that's because my URL is not correct. I have Fiddler here, and in Fiddler what I will do is hit my API. My API is really simple. It has a hello endpoint. I can give it my name, for example, and it will return a value. So if I hit this URL, you will see that it returns a status code 200, 200, 200, 200, and at a certain point, it starts returning 429 because I have too many requests over the past 5 seconds. If I now keep talking and distract you and wait for more than 5 seconds, you will see I get 200 again because my time period of 5 seconds has expired in this case. Really simple approach, and I think it works for a lot of cases that you are building, and I can even change the periods dynamically. If I want to do 10 seconds instead of 5, or maybe 1 minute instead of 5 seconds, I can easily change this in code and make this work because I have all the events in my database. Awesome. Anything wrong with this approach? Yes, I love all the answers. Thank you. We have an issue with our database. It will be slow. There's too many requests, too many events in the database. We have a lot of issues with the database. The nice thing is we can dynamically change our limits. The bad thing is we are basically killing SQL Server or MySQL or whatever is in the back. Because every request coming in is at least 2 to 3 queries on the database. I have my count, I have my insert, and I have my deletes. I could still postpone the deletes to run, for example, every 10 minutes, but typically at least 2 queries to just check if I can do something on the application. So that will hurt the database. I have constant index churn because I want this to be fast. I want to be able to search by user identifier and action identifier, and that means I will have to build an index in the database. And as you know, indexes can get fragmented and so on, so you will have a lot of churn and a lot of index rebuilding and defragmentation that will happen. The database will grow. The index will grow, the unused or fragmented space will grow, and our database will just need a lot of disk space and a lot of memory and a lot of CPU to just make this thing happen. So database is probably not the best idea to do this. Still, we can reuse the concepts of user identifier, action identifier, and a timestamp. Right, we basically made our application perform worse. We have an application that we want to throttle. We want to make sure that nobody can accidentally bring our application down because of too many requests. And now we are stressing the database. And if that database goes down, our rate limiting goes down, and probably our application is broken anyway. So that's not a good idea. You want to store the amount of requests for a user in a way simpler manner. Ideally, you just store +1, +1, +1, +1 every time the user comes in, and not do any other logic on top of that. So ideally, it's just a simple counter, and you can store that counter in buckets, as they call them. If you search the internet and you start researching application request throttling at ISPs and so on, they typically use one of 2 approaches. There's a couple of other ones, but quantized buckets is one of the more popular ones. Why quantized buckets? Well, the idea there is that you store the identifier and a time span that is normalized to the time span that you want to store. So in this case, if you look at this logic saying get bucket name, for about 10 minutes in this case, my identifier that comes out of this method will be the same. So if I request this once, I will get this some action, some timestamp identifier from this function. During the next 10 minutes, I will get that same identifier from this function. So that's really nice. If I would combine this with Redis, for example, I can simply store this as the key and then just +1 and keep count for this user. If after 10 minutes this key expires and a new key is generated because the logic says so, then I just have a new key in Redis and a new counter in Redis that I can start counting again. So quite easy to do. The nice thing is it's super and cheap. It's super fast, it's super cheap. There's not a lot of logic involved, it's just generating the identifier. The downside of this approach is that it's not accurate. It may not matter that it's accurate, but it may matter that it's accurate. So again, it depends on your type of application. Imagine you have buckets and you generate a new key every 10 seconds. What will happen is 4 requests come in, and my limit is 4 requests per 10 seconds. So everything is okay here. I have 4 requests per 10 seconds, 4 requests per 10 seconds, 4 requests per 10 seconds, right? Everything is nice. Except if I take my limits and I put that time frame there, we can see that we're actually exceeding the count of 4 requests per second. Because in here, I have 5 requests per second, and theoretically, I could even go to 6 requests per 10 seconds in this case. So it's not accurate. The timestamp will update, but because it only rolls over every 10 seconds in this case, I may be in between two of those things where you see more requests being handled than you actually want. May matter for your application, may not matter for your application. Again, it's fast, it's simple to implement. You decide whether it's the right approach. Another bucket type is the leaky buckets. So the best analogy is this image I found. You have a bucket, you have some holes in the bottom, and you have a flow rate. So you know when I pour in water in this bucket, the flow will, or the water will disappear from the bucket in a certain time frame. If you keep adding water, and the rate of adding water is lower than the rate that the water is being removed from the bucket, you're good. No limiting should happen. If you add more water than that can disappear through the holes in the buckets, then you know the bucket will overflow, and you know that you should be rate limiting. So that's another approach. Let's quickly look at the source code to see the main difference. So I have implemented 2 of these token buckets, and I basically created a pizza oven. So my pizza oven can only contain 5 pizzas every 5 seconds, and I want to make sure that I don't push 6 or 7 pizzas in my pizza oven. So if I use the quantized buckets and I run this, you will see that it generates some pizzas. Every second it adds a pizza, and you see all went fine. If I do a burst and I add a lot of pizzas, or try to add a lot of pizzas, you will see that at some point they are limited. Because my quantized bucket says, okay, for this period, the number of pizzas in the oven is too large. That's basically it. So nice demo, right? In source code, as I showed you in the slides, all that we do here is generate a bucket name every whatever the timestamp is. So my current bucket name is basically the leading factor in what the period for my rate limiting should be. All that I have to store, basically, is the name of my bucket as a key and the number of calls in my bucket as a value. If I exceed the number of tokens in my buckets, then I can just say, okay, you should be rate limited. If everything's fine, I just +1 and say, okay, you're fine, you're good to go through. That's typically it. Now, let's change to our leaky bucket. And you will see basically exactly the same demo. You will see pizzas are being added one by one and all is fine. And then I do a burst and it limits after 5. That's because I say only 5 pizzas per 5 seconds in this application. Now, for my leaky buckets, there's a little bit more work involved. I have to store the number of tokens that are left in my buckets, because I know whenever I consume a token, I should decrement this thing. And I should keep track of when I last re-added tokens into these buckets. I have to keep track of when I reset the number of tokens in there, and I have to keep track of the amount of tokens that I have in there. When I consume, I typically just consume and do a minus. If there's no tokens left, I throttle. If there's tokens left, I don't throttle. How do I calculate the number of calls that are left? Well, I just check if the number of tokens in my bucket are still is lower than my capacity. I check can I reset? If I can reset, I do a reset and store the timestamp. If I can't reset, I just return the current value of my token bucket. So not super complex. The main difference is that for quantized buckets, I should just store the counts. And for leaky buckets, I should store the counts as well as the timestamp when I did the last reset of this thing. Right, back to slides. So the main difference is it does rate limiting, both the quantized bucket as well as the leaky buckets, but the algorithm is a little bit different in what I should store and how I can implement it. Quantized bucket is simple, it's fast, and it's cheap to do because it's just a +1, but it's not as accurate as a leaky bucket. But for leaky buckets, I have to do some more work, like storing when was my bucket reset, as well as the counts. That may not be an issue, but imagine you are building a web application and you have to take into account concurrency and so on. You should do a lock-free type of algorithm where you store the timestamp and so on, whereas just +1 is way easier to do. So depending on whether you can live with slightly less accurate results of your buckets, quantized bucket is probably the way to go. If you really want accurate measurements, but do want to live with concurrency issues and so on, the leaky bucket is probably the way to go. Right, Redis is a really nice one to use as a bucket. So I just implemented this manually, and I still have to. My algorithm was basically not optimized for a web application because I didn't take into account concurrency. If you use Redis, you can easily do this if you want. So let's quickly look at. That's me. That's me again. Right. This is my. I knew this was going to happen. So this is my application. Again, nothing special, except that when I execute a request and I add an API key in there, I can do requests and you see they go through. But if I do more than 5 per second, I am being throttled here. I get back 429 status codes, and maybe not, and maybe yes, and maybe no, and so on. So again, rate limiting in action. The source code for this is, however, a little bit different. So in my throttling handler in this application, I'm making use of Redis sorted sets instead of just storing the value as a key value pair. So what I do is, anyone familiar or not familiar with Redis sorted sets? Okay. So a sorted set, what it does is it's basically a list that is sorted by the identifier or the key that you put in there. So more or less like a sorted hash set, I would say. What we do to do this rate limiting is we just add a new element to this sorted set, which is our current timestamp, in this case, the ticks of my current application. Because they are automatically sorted, if I request them from Redis, I get back the length of my number of elements in my sorted sets. So what I can do is say, okay, if the length is larger than 5, I can throttle. The interesting thing comes when it's not larger than 5, because then I can just add one to the sets, and if the set is full, Redis will automatically make sure that the older items disappear from this set. Why? Because I say, okay, I only want my set to contain the number of elements that I have in there, maximum 5, and everything after 5 I want to remove. So I basically abused the logic from this sorted sets to give me fault tolerance and concurrency a fault tolerance and a set that handles concurrency well. So that's what I want to do there. Right. So how much time do we have left? I think half an hour. Well, I think that's it. Throttling, awesome. Yay. Unfortunately, that's not it. There's a lot of things that we should think about in throttling. So the technical side, let's assume the technical side, we covered that. You either use a database and still crash and burn. You use your own store or use Redis or something, but you know you need a user identifier, an action identifier, and some key that you want to store. Now comes the thinking part. How do we put data into this technical thing that we want to work with? We have to decide on limits. That's the first thing we have to decide on. We have to decide which resources we want to limit. We have to decide on a sensible limit, because maybe 1 request per second is not the way to go. We have to come up with an identifier to limit on, because we saw that maybe just storing anonymous as the username is not the best way to go. And of course, like every rule, there's exceptions to the rule. We have to decide on exceptions. So let's dive in. What resources do we limit? Anyone? Everything. Thank you. Rate limit everything. The famous quote. What are sensible limits? Well, sensible limits are the limits that you see in your current traffic patterns in your application. If you have an existing application, there's basically two approaches to starting request limiting. One is looking at the server logs, figuring out the number of requests for a certain resource, setting the limits, and hoping for the best. That's one approach. It works quite well, because if everything is fine, you won't see a thing. If something is wrong or some limit is too aggressive for a specific resource, the customer will just email or send a support ticket or whatever. So it's a valid approach, but maybe not the best approach. A better approach, the one that we took, was figuring out the current number of requests, so basically guesstimating what the best limit for a certain resource would be, setting those limits, but instead of enforcing them, instead of blocking the request, we would just log to Logstash that we had a request that was limited, so that we could investigate, was this right, was this wrong, did we do a too aggressive limit on there or not? Basically, by analyzing those logs, we would be able to fine-tune the number of requests for a certain resource, and only then we would be sure that we could enforce the limit. So basically, if you want to introduce rate limiting in your application, just make sure that you log the fact that you are rate limiting, but don't limit immediately. Use that data to come up with more sensible limits. If you take this approach, it may still be that the user will call you in the end or send a support request ticket because something is still too aggressive, but at least you're more sure that the rate limits that you are enforcing are actually conforming to the traffic patterns that you have on your application. Another thing that you should decide on, will you allow bursting in the application? Imagine we want our application to handle 10 requests per second. If we take 10 requests per second, we extrapolate to 1 hour, we see 10 requests per second means 36,000 requests per hour. That's the logical linear way of deciding on the traffic pattern for our application. But maybe this is not the way to go. Maybe you want in your application to be able to handle 10 requests per second, but only 1,000 per hour, so that you can have bursts of 10 requests per second, but still limit the number of requests when you see that over a period of 1 hour, the resource is being abused. So you want to introduce a form of laddering. You may have linear request throttling, but typically in a lot of applications, you will see that you do want to allow some bursting in the application and have different limits per second, per minute, per hour, per day, per week, maybe per account even in your application. So if you look in this table, I have a couple of examples in there. You can have 10 requests per second and like the linear steady flow of 10 requests per second. In operation B, we can have a steady flow of a maximum number of 10 per second, but only 600 per hour. And in the last column, we allow bursts of up to 100 per second. But if you do that for 5 seconds, then you are limited for the next hour because we only allow 500 per hour. So that's another thing to think about. Are we going to do laddering or not? The next thing, of course, is what will be the identifier on which. How do we identify the user and the operation that comes in to make sure that we can decide on the limit there? Do we do per IP address? Could be a good approach, could be a bad approach, because typically in a lot of countries there's netting involved so that everyone is behind the same IP address. There may be a proxy where you only see the proxy's IP address and not the actual end user's IP address. So only IP address is probably not the way to go. Do you want to do per user? Well, that's fine. If you have the user, you can limit this one user to a certain amount of requests per second. But still, how do you limit anonymous users? Maybe by IP address and then anonymous. So you know somewhat, you somewhat know what the user is and what he's doing to your application. Maybe you want to store the identifier as a session identifier. But what if your application doesn't use sessions? If you build an API, for example, you typically just have requests that are coming in and no real concept of a session in the application. Do you limit per browser? Well, I wouldn't do it because a lot of people use the same browsers anyway. So typically, instead of just selecting one of these items, you will see that depending on the application, as well as the operation, you will decide on a combination of these things to build up the identifier of what you want to rate limit. Right. Exceptions. There's always exceptions. Do you rate limit all of your users, or do you want to enforce separate limits for some users? Typically, what you see is you may have some customers that apply for the regular rate limiting that you have in your application, but maybe you have this one really big customer that does a lot of requests. Maybe you want to apply different limits for that specific customer. Do we rate limit all IP addresses? What if I, as the owner of the application, hit my application? Do I want rate limiting? In a hair on fire situation where I have to check if the application is still running and so on, please don't rate limit myself. I don't want this because I want to see if the application is still working. Do I want to rate limit my monitoring tools? Probably not. If I have some monitoring tool pinging my application every second or a couple of times per second, I want that IP whitelisted to make sure that that IP address always is able to hit my application, because otherwise I would get false alerts. I would wake up in the night because of false alerts and text messages and so on. What with web crawlers? What if Google or Yandex visit our application? Do we limit them or not? Limiting them may make sense because you sort of shape the traffic, but limiting them may also mean that they enforce some sort of penalty in terms of SEO. So maybe you don't want to limit them. Again, up to you to decide, but still something to think about. There's also a really nice list of IP addresses online. I put the URL there. And those are typically the IP addresses that are used by data centers and not by end consumers. So imagine you are building a consumer application that you don't want other applications to hit, for example. You can find a list there with all co-location partners around the world and see, for example, what the IP ranges of Azure, of Amazon, of some large co-location vendors in Russia may be, and just block them more aggressively, or not, depending on your application again. Okay, cool. How do we respond to limits? What do we do when a user comes in and we limit this user? There's a couple of options. We can just black hole and just do nothing. When the user is limited, we just don't respond and keep the connection open or whatever. The user will never know that they were throttled, but they will also never get a response. I don't think black holing and closing the connection is the way to go. I would say always tell the user about the fact that he's being throttled. On an API, the least you could do is return something like a 429 status code saying they are making too many requests to the application. I don't know, is anyone active on Stack Overflow? Okay, I always have this on Stack Overflow. I see a question, I answer the question, I press post, then it appears that I'm not logged in, but Chrome remembers my credentials, so I just click login and post again, too fast, and I always see this one. Stack Overflow is rate limiting my comments, and they are telling me with a human verification. They are just saying, okay, you do too many requests per second. We want to make sure that you're not a bot. And if I just enter this CAPTCHA, they just let me through and I'm fine to go. Tell your users that they are being throttled, and this is a nice way to do it. In an API, you could look at the accepts header in HTTP. So for example, if you have an API that serves up both XML and JSON and HTML, you can just look at this API header to see what response you want to return, maybe a web page, maybe an API result. Tell them why they are being throttled. Ideally, you return a 429 too many requests with an additional header telling them to look at your documentation, for example. Why are they being throttled? Give them as much information as you can to decide on why they are being throttled. GitHub is a really nice example because for every request you make to them, they give back headers that say, okay, what is the limit that you are subject to? How many requests are remaining within that limit, and when do we reset? I think that's a really nice way of doing things because they really tell me what can I do in my application? How many requests do I still have left in the application? Right, where do we limit? That's another interesting one. Where do we limit? Well, the naive approach again would be going to NuGet and searching for throttling or rate limiting or whatever and making use of one of these libraries. They are awesome. They perfectly do whatever they promise. MVC throttle runs as an action filter, just limits per IP address, per time span. Lots of different options. It's perfect. Same thing with OIN.limits. This one doesn't run as an action filter. It runs as a middleware. So it gives you information like bandwidth, current requests, and so on. The only thing is, since it runs as a middleware, it doesn't have the notion of knowing that we have a controller or an action and so on. So again, you see, if we run as an action filter, we have more information available. For example, the action or the controller that we have. If we just run as a middleware, we know we have less information because we're somewhere else in the pipeline to do our rate limiting. But it works fine, and it just does what it should be doing. So let's look at MVC throttle quickly. That's me again. Right. Let's run our application. It's a very simple ASP.NET MVC application that has an API, a simple blog, an about page, and so on. And if we go to our about page, nothing happens. If we go there a couple of times, you will see that at some point we get this message saying we are rate limited. Again, tell your users, and this library gives that functionality out of the box. The only thing that I have to do is enable the library, and you get something like this. So the way MVC throttle works is that it's registered as an action filter. You can do it either globally or per action in your ASP.NET MVC application. So here for our about page, we have enable throttling. We say we want 2 per second, 5 per minute, which means we are applying laddering. We can do a burst of 2 requests per second, but after 5, we are limited per minute. If we enable throttling, we get the throttling functionality. If we would enable it on the controller level, we can still disable it for some actions if we want to. So really easy to do. MVC throttle has logging, so you can do logging like saying, okay, this request is being throttled. You can use MVC throttle to create that log of the fact that you are being throttled, but not enforce the throttling. So this, again, does what you want to have in there. We can create custom filters that have different things like, okay, look, I want to check the accept type, and if I have HTML, I return a view. If not, I return some JSON, for example. So again, I can decide based on the accepts header, as you can see here. If it contains HTML, we return a view. If not, we return the default, which is some JSON data. What else is in there? There's actually a lot in there. This library also has some configuration where you can say, okay, I want to have a throttle policy which is per IP. So by default, every action will be throttled at 2 per second, 10 per minute, 60 or 600 per hour, and so on. But I want to scope this to IPs. And I want to say, okay, this specific IP, which is my local host in IPv6, gets 15 requests per hour. This IP may get 30 per minute. This IP may get more. This IP may get less, and so on. I have a whitelist in there as well. If I serve using my local host, I don't get any rate limiting, the default one at least. If I'm Googlebot, for example, or Bingbot, or Yandex, or whatever, I'm not being throttled. I can define this in this library based on the IP address. I can do client throttling. I can say, okay, look at the authorization header to apply throttling there. I can apply throttling on my actions and my controllers. If I want to say, okay, I have different endpoints and I just want to throttle on the request path, I can do so as well. I can scope to user agents, add different rules, add logging, add whatever I want. So everything that I've talked about so far during this talk is available in the MVC throttle package. And if you want to start with it, I would say start with this one because it gives you a lot of options and flexibility in terms of just logging or maybe logging and enforcing and so on. Right. If you remember the previous slide that I had, you will see that we could throttle in the controller's action, or we could throttle using this other package in the middleware. How far do we allow traffic before saying you are being throttled? There's a couple of options we can do. MVC throttle basically lives in the application. The traffic comes into our application, and only then we throttle the user in our application. We could do in the framework, if we would use a middleware, for example, we're one layer before our application, and we're throttling in the middleware. We could do rate limiting in the process or maybe on the server, configuring IIS to apply throttling. We could add some device in the edge of our data center and limit there. Or we could use some CDN, for example, that limits on the CDN side and doesn't even send the traffic into our data center. So there's a lot of places where we can apply throttling, and the question is, how far do we allow traffic to go? I'll change the view there, because the further down this hierarchy you go, the more knowledge you have about the operation that is being performed. The further out, the less knowledge you have. But the further down, the more resources you spend on handling traffic that you maybe should not be handling. But the further out, again, you spend less resources, but you know less about the user. So if we look at it like this, if you do it in an action filter, you have a lot of knowledge about the user. You know who the user is. You know which controller action they are hitting. You know they are authenticated. You may have temp data available, session data, whatever you want to have in there. But you have a lot of resources that are spent. If the user comes into my application and I have to do authentication, I have to invoke the MVC pipeline and so on, I'm spending resources on something that I may not want to spend resources on because I want to apply rate limiting. But of course, I have more knowledge. So that's the two factors that you should balance in there. What options are there? In our application, we have already seen that we can apply rate limiting in an action filter or a middleware or maybe in an HTTP module. Those are easy because you have all the knowledge about your user. You know what they are trying to do. You know they are logged in. You may know what they did previously. You may have session information available, etc. It's easy to add custom logic because you have all that information available. So if you want to throttle only if their shopping cart is not empty yet, you can do so, because you have all that information available. You can throttle on the server. I don't know if anyone tried the different IIS modules to throttle on the IIS level, for example. There's a couple of nice things in there. I can apply dynamic IP restrictions, where IIS will basically keep track of all the different IP addresses that are coming in. And I can say, okay, every IP address can have 5 requests per second, for example, and IIS will handle the limits for me. I can do bitrate throttling, which is not on the number of requests, but on the bandwidth that is being consumed. And there's in the web config, you can add the limits elements. There's a couple of things that you can tweak there as well. If you're not using IIS and you're using ASP.NET Core and Kestrel, you can set some minimum speed, maximum speed. There's some throttling built into Kestrel as well. Now, from experience, I found rate limiting on the server, so in IIS or Kestrel, is more difficult because those are typically libraries that are outside of your control and they do some really strange things. If you look at IIS dynamic IP restrictions, for example, what they do is when you are being throttled, they return a 403 forbidden. Okay, fine, you don't get access to the application, but typically that would mean that MVC would redirect to my login page and my login page would get all the traffic. So it doesn't really make a lot of sense to do it in this case. Also, the fact that they are HTTP modules in IIS means that I'm still spending threads and I'm still spending process time and memory and so on in IIS. So I'm not a big fan of this approach, but it is something that you can do. Outside of our server is something that we are currently looking at by using some sort of a reverse proxy to basically throttle on, outside of our service. Put a layer in front of the server where all the traffic comes in, and only if this layer lets the traffic through, then you hit your server. You can do this using IIS application requests routing. You can do that. You can use something like Nginx or HA proxy or Squid or whatever technique you want to use there. The nice thing about this approach is that the traffic is blocked before it even reaches our application server, which means we spend no logic that could otherwise serve real customers or real users and so on. We block before. Let's look at how you can do this with Nginx, because it's actually really surprising easily. Anyone want to see more pictures? Let's not go there. Okay. So I'll first give you a nice demo. I have on my local machine Nginx running, and Nginx on my machine in a Docker image is configured to go out to our live web application. So if I go to, let's say, localhost port 8080, we will see that I hit my Nginx on my machine, which proxies our actual production application at this moment. We can refresh, we can browse the different pages, it just works. What I can also do is go to a specific feed, let's say Google Analytics Tracker for some packages, I get that traffic back. Now, if I hit this a couple of times, it just returns. But if I increase the rate of requests going to this page, you will see, there we are, 429 too many requests served by Nginx. So Nginx is throttling on my machine, and my application doesn't even know that traffic is being throttled because it doesn't even hit my application. So Nginx is blocking outside of my application, which is really nice to have. So how do you do this? Well, in Nginx, there's a couple of concepts you should know. The configuration is somewhat like a DSL building the configuration. And I say, okay, I want to run an HTTP server in my application. My HTTP server will listen on port 80 and will have different locations specified. So everything that is after slash will be forwarded to our actual production application. We don't do redirects, we really forward the traffic and serve it back from our Nginx proxy. We add some headers because maybe I want to know inside my application what the IP address of my end user is. By adding this header, my application will actually know my real IP address instead of the IP address of my Nginx edge server. Nice thing about Nginx is that it can just proxy and just transparently forward traffic to another location, but we can also do real proxying and caching. So for content, which is where our images and JavaScript and CSS and so on live, what I do is I do the same thing. I just pass it on to my production application. I add these headers, but I'm also saying, okay, cache these requests for 10 minutes, except when you get back a timeout, an error, an invalid header, HTTP 500, 502, 503, or 504. Blah, blah. The idea of this approach is, since I have this proxy server in front of my application anyway, we can use it for both request throttling as well as real caching in the application. So if you would look at some image that lives on the website, let's go back to our website. Yeah, there we are. If we would look at this image, for example, inspect, that's the image. If I would go to my local hosts and so on, 80, that will still serve up the image. But the nice thing is, if I would do this in Fiddler, I can even add some additional headers saying, okay, this thing is proxied by Nginx. So if we would look at this thing, you would see that we have X cache status is hit. So this header is added by Nginx, informing me as the application developer that I'm actually not even hitting my application to serve up this resource. Okay, back to request throttling. There was one path that I was actually throttling, which is the path where the feeds live in the application. So if we go back to our configuration, I have this /f, which is where Maven, NuGet, NPM, and so on live. What I do there is, again, passing on the traffic to my production application, not redirecting, really passing the traffic through, adding the headers as well. But I say, okay, I want to limit requests defined by my limits. We'll go there in a minute. I want to allow bursts of up to 5 requests per second. And if this thing fails, I want you to return a 429. We've seen the error page is really ugly and it's just boilerplate Nginx. You can customize the configuration to serve up a different page or maybe some JSON data or whatever, just like we saw in a previous example. This my limit, how is it configured? It's not really difficult. This limit is configured like this, where we say, okay, I want to limit requests and I want to call this zone my limit, and I want to limit these requests by the binary remote address. So what Nginx does in this case is just take my IP address, convert it to binary, and use that as the key for my request throttling. I say I want to allow 2 requests per second normally, but again, we overrode that in our specific path, saying, okay, we want to allow bursts of up to 5 requests per second. My zone should be valid for 10 minutes, and this one will actually use a Leaky buckets implementation, so it will keep track of a real window of 10 minutes instead of the quantized bucket approach. Now again, I told you that just using the IP address as the way to do limiting is probably not the way to go, and that holds true in Nginx as well. So typically what you would do is create a different key in the configuration. And as you can see, I commented out this one, but you could use a concatenation, for example, of the IP address and the authorization header, or maybe IP address and some API key header, or whatever you use to identify your users in your application. So as you can see, it looks a bit funky, but if you look into it, it's not really that hard to do. And it's really good because I'm filtering outside of my application, and my application doesn't even get the traffic that my user is sending it. So that's a good thing. Right. Another option that we can apply is rate limiting using something that is outside of our data center. You may have seen CloudFlare, you may have seen Azure API management, and so on. Those are typically services that live out there. And if you want to use them to block requests to your application, you just point the DNS to their service. They will forward to your application, and that's it. They will be the Nginx, but without you having to maintain it. A nice thing, if you look at CloudFlare, for example, is that they are a combination of a rate limiter and a CDN, which means you have a rate limiter in some 180 locations around the globe doing the rate limiting for you, and the traffic is not even hitting your data center if they rate limit for you. So that's really nice. The downside to that is it's a little bit less in control, and it's a little bit more expensive typically. Right, so in conclusion, because I see I only have 5 minutes left, users are crazy, but we've discussed that before. They don't mean to be crazy, they just use your application, they have their expectations about your application, and that may be the wrong expectations, but you as the application builder still have to cope with that type of traffic. We need rate limiting to overcome this, but also to overcome other malicious traffic patterns that we may have in the application. To do rate limiting, we have to decide on the resources we want to limit. Again, everything. We want to decide on the service on a sensible limit. Again, think about looking into your logs and maybe not throttling from day one, but just logging the fact that people could be throttled in this case. You have to come up with a good identifier to limit on. I didn't really touch on this too deeply, but you may want to do this per resource. Some resources may be per IP, some others may be IP and authorization header and so on, so it could be different per resource. Decide on exceptions. Don't rate limit your monitoring system. Don't rate limit yourself maybe, because in case you have a hair on fire situation, you want to be able to troubleshoot your application and see what is going on in there. What to do when the user reaches a limit? The answer is simple. Always tell them they are being throttled, tell them why, give them a link to the documentation, somehow inform them about the fact that they are rate limited and what they could do to overcome this rate limitation. And then, of course, decide where you want to limit. Deeper down the application stack, you have more information available, but that also means you spend more resources on handling traffic that you may not want to be handling. So think about where you want to rate limits. That's it, I think. Thank you.